Okay guys, given a question like this, of course the first thing we should do is turn it into an augmented matrix. And remember what the goal is after that. We have to take this augmented matrix and turn the left side into an identity matrix. This makes it easier for us to see what the values of x, y, and z are. The first thing we should do when dealing with an augmented matrix is making the top left corner a 1. So here what we're going to do is we're going to divide the first row by 3. As you can see, all the other terms are not a multiple of 3, so we're going to get a lot of fractions here. It's not the end of the world, but you got to be careful when you're computing these fractions. Our next goal is to get zeros underneath our first row leading coefficient. So the first thing we should probably do is get rid of that 4. Now what we could do is multiply the first row by -4 and add it to the second row, but I want to avoid using fractions as much as possible. So what I'm going to do instead is I'm going to take the third row, multiply it by -2, and then add it to the second row. This will minimize the amount of fractions we'll be dealing with. Now we got to cancel out that 2. What I'm going to do next seems like it's the long way, and it is, but the reason why I'm doing this method is because I want to avoid fractions at all costs. In my personal experience, when it comes to exams, I always lose points because of some silly mistake on a fraction. So let's avoid that. I'm going to start by multiplying the first row by -6. And then I'm going to multiply the third row by 3. Now you see that the leading coefficient in row 1 is the negative of the leading coefficient of row 3. So what we're going to do next is add row 1 to row 3. So you can see we got rid of 2, all while avoiding fractions. Of course you can use other methods to cancel out that 2, but I feel that this is the safest way. Let's simplify a little here. I'm going to divide row 3 by 13 to get a 1 in that second column. Remember, there are many ways to get to the same goal. The path that I'm going to choose is to next cancel out that -5. I'm going to do this by multiplying row 3 by 5 and then adding it to row 2. And then I'll simplify by dividing row 2 by -3. This will result in a 1 occurring in the third column. Let's take a second to review what our goal was again. We want to create a matrix where there's 1s in the diagonal and there's all zeros underneath those 1s. Our current matrix is actually in that form, but it's a little disguised. See, if we switch around the second and the third row, you can see we have achieved in getting 1s all across the diagonal, and we have zeros all underneath them. Now our goal is to eliminate all the numbers above 1 in the upper right triangle. Let's first start by canceling out the -2. We're going to do this by multiplying the third row by 2 and then adding it to row 2. Using the same tactics, we can cancel out the -2/3 and the 7/3. And there we have it. We have an identity matrix on the left-hand side. So what does this mean for us? It tells us that x equals 2, y equals 1, and z equals 3.